everyone, welcome back to the next seminar series in Mapping Ancient Africa. It is me again, Steph, who's going to give you through this wonderful presentation that we're expecting today from Bruk Lemma. So Bruk is a postdoc currently stationed at the Luther University Halle-Wittenberg, but he's going to give his talk about his homeland, which is Ethiopia, and particularly he's going to concentrate on biomarkers and stereo isotopes to unraveling the paleoclimate dynamics of parts of Ethiopia that he wants to concentrate on. So with this having said, just so everybody's aware, we are recording this and then putting it back on YouTube afterwards. So if you have to drop out, no props, you can always catch up. And if Bruk is going to do his talk, and then afterwards we're going to switch to the discussion round. So with no further ado, happy to hand over to you, Bruk. Stage is all yours.
Okay. Thank you very much, Stephanie, for your nice introduction. And I appreciate you all joining this webinar. Please do not expect any age depth model or paleosedimentary records which usually presented in Mapping Ancient Africa seminar. So with this, I will proceed to my actual presentation. So today I'm trying to give you a discussion regarding to biomarkers, mainly biomarkers from the Bale Mountains. Over the last few years, I made an endeavor towards identifying unambiguous molecular markers for paleo extent, for reconstructing the paleo extent of aircraft vegetation in the Bale Mountains. We tried to reconstruct the paleo extent of Erica in the Senate Plateau in the Bale Mountains. So in a few minutes, we spent together in one of the most wonderful and nature-endowed national park. Just to introduce you the study area, Ethiopia is a country located in Horn of Africa, and the Bale Mountains located in the southeast of Ethiopia. The Bale Mountain National Park is part of the Eastern Afro-Mountain Biodiversity Hotspot. That means the place is known by endemic flora and fauna, and also endangered species, just to mention the Ethiopian wolf. The Bale Mountain National Park generally divided into 4 vegetation zones, of which the Ericaceous belt is one of the vegetation zone we can mention, and the other one is the Afro-Alpine belt, which is located in the center. The Afro-Alpine vegetation is mainly composed of grasses like Festuca basilicata and alpine plants like Helichrysum splendidum, Lobelia rhynchopetalum, Alchemilla humani, and Erica in the form of fudge. And you may also find lower plant community like mosses and lichens. If you are interested to study the paleoecology of the Bale Mountains, you may be aware of 2 fascinating scenarios. I call it them climate versus human impact scenarios. The study results mainly from the glacial cirque lake called the Gabraguracha shows. At the very beginning of Holocene, the Senate Plateau is covered by Erica, mainly associated with increase in moisture and temperature. Whereas around 6,000 years before present and onwards, Erica retreated to lower elevation due to decrease in precipitation. And also human encroachment associated with burning, highly responsible for drastic reductions of Erica to the lower altitude. So these are the 2 scenarios which you can find dealing with paleovegetation and paleoclimate in the Bale Mountains. So currently, the present extent of vegetation covered, that means the type, abundance, and distribution in the Bale Mountain, is a legacy of subsequent ecological processes, primarily influenced by anthropogenic impacts like fire, overgrazing, and agriculture, and also related to climate like frost and drought. So this photo reveals the current fire event in Ericaceous belt. Currently, the Erica in the Bale Mountains distributed densely in the Ericaceous belt And also in the Senate Plateau, you find Erica in the form of patches. That means you find Erica relict only. So here is our hypothesis come. We assume that Erica grow up in the Senate Plateau as densely as in the Ericaceous belt did in the past. So in order to test our hypothesis, we pose two research questions. The first one is just we ask, do plant-derived molecular markers unambiguously allow identifications of Erica vegetation? And the second research question is, do plant-derived molecular markers reflect the isotopic compositions of the contemporary precipitation in the Bale Mountain? Before I jump into the next section, I would like to give you a very brief introduction about molecular markers. I know most of you presented today in this webinar have a better understanding of different molecular fossils, but for the sake of creating a common background for all, I would like to give you a brief introduction to lignin and enalkanes. Lignins are one of the most important secondary metabolites that has a polyphenolic biochemical structure produced exclusively by vascular plants. They provide strength and rigidity to the plant. Actually, there are three monomers of lignin. We name it vanillin, stringile, and cinnamide. The three monomers of lignins, they have functional groups, acid, ketone, and halide. We use a different ratio of lignin monomers as a proxy for paleovegetation or chemotaxonomic study. For example, the ratio of C/V, cinnamide versus vanillin, can be used as a proxy to distinguish grasses from non-grass vegetation. And also the ratio for stringile versus vanillin can be used to differentiate angiosperm from gymnosperm. Enalkanes are acyclic hydrocarbon with a chemical formula of CnH2n plus 2, and they are important constituent of plant leaf wax. Due to their recalcitrant nature, we use also enalkanes for paleoclimate and chemotaxonomic study. For example, carbon chain lengths of C27 and C29 used to characterize trees and shrubs, and also higher carbon chain lengths like C31 and C33 used as a proxy for identifying grasses and herbs. So in order to test and in order to find an ambiguous Erica marker, we collected we collected leaf, organic surface layer, and a horizon mineral topsoil along the southwest and northeast transects in the Bale Mountain. Lignin phenols are extracted using cupric oxide oxidation method developed by Hetz and Ertel. And also lignins, lipids, particularly enalkanes, are extracted using SOxFlate and fractionated, as well as purified under aminopropyl polymer, followed a method by Zek and Plaza. So let me jump into my results and discussion. I will present and discuss two parts. The first part mainly focus on biomarkers, mainly lignin and enalkane. The second part is focused on compound-specific stable isotopes. Just to begin with presenting results regarding to lignin. So the agglomerative hierarchical cluster analysis using a total lignin concentration allows us chemotaxonomic identifications of the keystone plant species in the Bale Mountains. As you can see, there is a very nice cluster, but this dendrogram does not show apparently which lignin monomers are responsible for making such a nice cluster. So further, we try to study our data set by computing triangular coordinate system. So this ternary diagram shows to you, even if it is scattered, the cinnamide contributions of Erica greater than 40% characterize Erica. So we use the ratio of C/VSC as a proxy to distinguish Erica from the other keystone plant species in the Bale Mountain. But still you can see there is a partial overlap. So we want to see if this is this partial overlapping is an artifact or reality, So we add and we investigate our existing data set together with new ERICA sample set. So this XY plot shows a cinnamide contribution greater than 0.21 and benzoic acid greater than 0.06 can be used to characterize ERICA in the Senate Plateau. So this cinnamide and benzoic acid can be used as a key variable for chemotaxonomic study of ERICA. So we are very engrossed to see this characteristic cinnamide and benzoic acid in organic layer and A horizon mineral topsoil. So the sum of lignin phenol shows a decreasing pattern. It decreased from plant to organic layer and A horizon mineral topsoil, except for Helichrysum splendidum. This result is in a good agreement with other research finding, but it is not interesting for us to see such a descending pattern because such descending trend is showing degradations of lignin during organic matter decomposition. Let us see this result. If you look at this box plot, notched box plot, the characteristics cinnamide contribution by ERICA greater than 40% is lost in the soil under ERICA, whereas the cinnamide contribution by Festica abyssinica under the soil shows greater than 40%. So this is a complete shift of result. This can be explained by two reasons. One is there is a selective degradation of cinnamide phenol, and also it could be underground inputs by roots. So far, we discussed the potential and limitations of enal lipid lignin for chemotaxonomy and paleoclimate researches in the Bale Mountains. Now I will proceed to discuss the potential and limitations of N-alkanes. Unlike lignin, N-alkanes, the agglomerative phylocyte cluster analysis using total alkane concentration does not enable us to distinguish ERICA from other vegetation, but like lignin, the total alkane concentration shows decrease along vertical decreasing of like from plant to organic layer and A horizon mineral topsoil. So there is an indications of degradation also happening in total alkane concentration. One of the proxy we use in N-alkanes, it's called the average tail length. It's a proxy for a source of organic matter, and it shows change in the inputs of vegetation type. For the soil, the value ranges from 29 to 31. This means the dominant proportions of N-alkanes are mainly originated from terrestrial leaf wax. If you look at this ternary diagram, Festuca abyssinica, the grass, is mainly characterized by predominance of C31, which is in a good agreement with other researchers. Exceptionally, Nifofia pelosa is characterized by C27. Therefore, we can say C27 can be used as a robust proxy for Nifofia pelosa, but unfortunately, we don't have much data set to discuss that C27 can be used as a proxy for identifying Nifofia pelosa in paleo sediments. Apart from individual N-alkanes and also total alkane concentration, low ratio of C31 and C29 can be used to characterize ERICA, except from Helichrysum splendidum. This ratio is not strong enough to characterize ERICA. The other proxy we used in N-alkanes is called odd-even predominance, sometimes also referred to as carbon preference index. It is a proxy for degradation. So the value shows variation among the modern planters, and also there is a decrease along depth. So it decreased from leaves to organic layer and A horizon mineral topsoil. So it is prudent to discard using carbon preference index as a quantitative indicator of N-alkane degradation in a sediment or a proxy for degradation, at least in the Bale Mountain. So far, we discussed the potential and limitations of biomarker for paleo vegetation reconstruction in the Bale Mountains. Now and onwards, I will discuss results related to compound-specific stable isotopes. As you know, plants use water for their growth and for the synthesis of different molecules. So we are interested to see how plant responds to different moisture sources using stable isotopes. So deuterium N alkane values and also delta 18O sugar values of the plant's organic layer and air horizon mineral topsoil do not show any significant difference. So our results do not provide any effects which is coming from degradation or root inputs. So our isotopes values do not affected by degradation and also root input, which is not the case for our biomarker. As you remember, our biomarkers are affected either by degradation, selective degradations of cinnamomyle, or underground input by roots. The keystone plant species in the Bale Mountains are characterized significantly by deuterium N alkanes and delta 18O species-dependent trend. So this species-dependent trend can be explained by plant intrinsic factors like plant physiological and phenological differences, or it could be like plant growth form. It could be like monocot, dicots, or you can see differences in the place and time of leaf synthesis. If you look to the values, for example, Erica is characterized by less negative deuterium values and more positive delta 18O sugar values. Whereas Festuca abyssinica, which is grass, is characterized by more negative deuterium value and less positive delta 18O values. This can be explained by signal dampening caused by leaf basal. So you can see clearly that our species, compound-specific stable isotope shows a species-dependent trend. So in order, just to conclude my talk, it is possible to characterize the keystone plant species in the Bale Mountains using lignin phenols and N alkanes. However, it's better to give a caution for degradation and root inputs. So its implication for paleovegetation reconstruction is hindered by soil degradation and root inputs. So it's better to look for other alternative robust molecular marker like terpenoids. At the moment, I'm dealing with terpenoids, which shows a very promising result. I will present to the public soon. And also, we recommended to consider vegetation change, particularly in terms of grass versus non-grass vegetation change, while using deuterium N alkanes and delta 18O sugar records, at least in the Bale Mountains. So with this, thank you very much.
Thank you very much, Bruk, for this really wonderful talk. I'm gonna go and open the floor for questions from everybody. Anybody got some questions? Will, go ahead.
Yeah, thank you. Super talk, and nice to see some N-alkane work. I've thought about this in South America, but not in Africa. I was just wondering, like, with a view to the paleo environment, paleo climate stuff, whether you could comment on the preservation and the application of this more broadly to actually into paleo environmental signals. So what are your thoughts on that, and how much can we expect from this approach?
Yeah, from the chemical point of view, N-alkanes are preserved well, especially in lacustrine sediments. It depends on the type of archive we are looking for. If you look at lake sediments, you can get easily N-alkanes. But other sediments, let's say low paleosoil sediments, you may not get a clear abundance of N alkanes because of degradation or because of the nature of the sediment. The other thing, yeah, you can use N alkane for paleovegetation reconstruction, and also isotopes from the N alkanes can be used for paleoclimate studies. So it's possible.
Okay. And my second question was just a bit more random. But Stephanie and I are thinking a lot about fire at the moment. And you mentioned that humans were introducing fire into this area. My question was very simple. What is burning in this environment? Is it just the erica, or is there other elements of the vegetation that are really catching fire and burning?
People are interested in burning erica because they want to have a new grass to come. And also they want to burn erica because they need to have a very palatable erica leaves. So the young erica leaves is more palatable compared to the old one. And if you leave erica for greater than, let's say, 5 years, erica become a tree.
Yeah.
So it's not easily accessible for animals. So this is the reason why people go to burn fire in.
Okay.
So
cool.
they ignite. Yeah.
They do the same thing in England on the moorlands. They burn the heather so that you get the erica resprouting, so that the grouse can eat it, and then they can shoot them with their guns. But that's a slightly different story. But yeah, thank you. That was very helpful. Okay. Thank you.
Yeah, thank you for the question also.
Perfect. Any other questions? If everyone else is shy for now, I do have a question back to the fire. I do know that you can use biomarkers to trace fire, right? Have you looked at that in the region just for the sake of the argument, or is it something you have not touched on at all? Like, since I'm not usually working with biomarkers, I'm just really curious.
Yeah, actually, the Ericaceous belt is also checked in terms of its resilience to fire or not. So it shows that the Ericaceous belt is resilient for fire, and it is a known trend. So it is already studied by Graciela, one of our colleague or member of the project, the Bale Mountains Exile project. So she studied using pollen and also charcoal, the resilience of Ericaceous belt in the Bale Mountains. So, and also you can use black carbon, not only charcoal. You can use black carbon also to study the fire history.
Okay, thank you very much. Anyone else got a question? No. In which case, I have more. Oh, no, there's a question. Hi, Gemma, go ahead. We can't hear you, Gemma, sorry. We don't hear your audio. Like, I can see your microphone is on, but I can't hear any audio. I'm unmuted, but on the browser. Okay.
Maybe she can type the question.
Yeah, she will go ahead. Okay, we're gonna squeeze another question in while Gemma's typing out her question. Anyone else? If not, I'm gonna throw in another question, just out of curiosity. How do you think like this developed in terms of longer time scale? Because what you looked at is mostly Holocene in age, right?
Yeah.
Okay, so
actually, my work is only looking to the modern or the contemporary plant organic layer and a horizon mineral topsoil.
do you have any idea how particularly the Erica stuff changed over longer periods of time? Is it something that if you're thinking like 100,000 years, was a dramatic change within in the vegetation? Because I have no idea, so that's why I'm asking.
Yeah, just based on the result from Lacustrine sediment, it shows Erica was extended towards the plateau during the onset of Holocene, which is mostly associated with increase in precipitation and temperature. But when the temperature drops and precipitation drops, Erica is retreated to the lower altitude.
Okay.
So it forms the Ericaceous belt. So this is a question we raised. Why Erica is not dense as the Ericaceous belt in the Senate Plateau? So in order to check this, we need to have an ambiguous Erica marker. So this is the task I have and work towards finding best suited Erica marker for value vegetation reconstruction. So you find Erica in different distribution, in different abundance.
Okay, so based on the marker, you know, defined how far back in time could you take it, because you still need organic matter to be preserved in order to measure it, right?
Exactly. Yeah. Especially for biomarkers, we need sufficient amount of organic matter to be preserved.
All right.
Just to jump in on that, and it makes me feel bad because we haven't published it yet, but we do have organic biomarkers that are 500,000 years old from the Eastern Andean flank. So the preservation in the right conditions, it's totally possible to get these out of really old sediments.
All right. That's really cool. I'm gonna jump to Gemma's question since she went through all the trouble of, okay, it's a lengthy one. So I just gonna read your message out. Brooke said it was a great talk. My question is coming from the perspective of a palynologist. I was really interested to see that you are looking for signatures at the species and genus level. I was interested in your target species selection and wondering how well this approach would translate to situations where you have quite a diverse range of species that may be important. I assume there is a need to group taxa at a higher level.
Yeah, one of the problem for biomarkers, it doesn't zoom down to the species level mostly. So that's why many researchers want to categorize vegetation into like gymnosperm, angiosperm. This is a very big class or hierarchical division. Or they go to the family level, but we are interested to see at a species level, and we want to test if it is possible or not. So of course, so far, it's possible for the modern vegetation, but this pattern is changed down depths. We can't find the imprint of, let's say, N-alkanes and also the imprints of lignin in organic layer and A horizon. But a diverse molecular marker like terpenoid, for example, they can be goes to species level. Different research shows this is possible. So individual species, they have their own specific character, especially in terms of terpenoids. So that's why I'm zooming to terpenoids and try to discuss the difference of abundance of pentacyclic triterpenoids in the keystone plant species in the Bale Mountains. So you said right. It's hard to characterize individual species based on their N-alkanes and also lignin, but because of diverse abundance of, for example, terpenoids, it is possible.
Thank you very much, Brooke. Does this answer your question, Gemma? Perfect. Just as a stupid afterthought, then the one that you can trace down to species level, is it something that's always as a marker there for other vegetation stuff, or is it like limited to Erica, or could you use other species as well that are not related directly to Erica to trace with it?
Biomarker is a very general term.
Yeah.
So, but we have different secondary metabolites. If you look to lipids, we mainly focus on N-alkanes. So N-alkanes, we use long chain carbon, like C27 or C29, or it could be C31 or C33. These are individual carbon chain can be used for woody plants or tree and shrubs, and also like non-woody plants like grasses or herbs. So it's a big classes. You can't see like this is Erica and this is Alchemilla or other vegetation. But you can find from this carbon chain, you can find out a proxy, like different ratios. For example, the low ratio of C31 and C29 for us used to characterize at least the leaf of Erica from others, because the leaf of Erica shows low ratio.
Okay.
So we are interested to find a more different ratios to characterize Erica from the other vegetation. So that's why we need to have a more calibrated studies in a specific region, because people use different ratios for different segments. So that's why we want to also have our own proxy for that specific area.
All right, that's perfect. Thank you so much. So any other questions? No, I think that's it. If there's nothing else, in which case, Bruk, thank you very much again for your really wonderful talk and all your really nice comments. I think that was really good to get an overview. At least I can say that from someone who usually doesn't work with biomarkers, to get an overview like that. So thank you very, very much for that. I will put the video via Will on YouTube, hopefully sometime soon, so everybody can catch up later. And the next talk will be in about 4 weeks in April, and this one will be given by Soline Bossard. Is that pronounced anywhere near what it should be, Will?
You're not asking a French speaker here, so
I know, but
I'm
maybe
not
you
the
know
right
better
person
than
to
me.
advise on French pronunciations. Sorry.
Okay, in any case, please check out Ecology of the Past for the up-to-date seminar talk outline. And then I'll be happy, like I wish you a really nice weekend everywhere you are. And then I'll be happy to see you again in about 4 weeks' time for our next talk. So if there's no other issues, thank
Thanks
you
a lot.
very much.
Yeah. Thank you very much also for the questions and presentations.
No
Yeah.
problem. Thank you very
Yeah.
much.
Ciao, ciao.